Today on the bench I have an HP3330B Automatic Synthesizer, and this is actually part of a network analyzer system which also utilises an HP3040A. I bought this quite a few years ago now, and I did some work on it. This panel here was all beaten up, and I didn't get a good colour match to replace the paint on here, and one of the things I want to do is actually redo that. Also, we've had a switch tang here break off. I still have the push button cap, so that needs to be repaired. And I can't remember where I got to finally, but certainly there's a special HPIB cable for this and the 3570A that I had to make up, plus a triax cable that goes from an output on this to the 3570A. Those cables were made up, and I do remember the unit was running. What I wanted to do today was to revisit this and just get an idea of what needs to be done. But first up, let's just fire it up and see what happens. Well, it's come up, but it doesn't appear. It looks like whatever process is in it is frozen. I can't select frequency or amplitude values. It just won't let me set anything, and so we'll have to look into that. So okay, first thing we do is let's pull the cover off and have a bit of a look. On the main motherboard of the 3330B, there's all of the, well, not all, but quite a few of the signals and rail voltages are listed against pins going into the various cards. So I've gone around and done a complete check of rail voltages. There's quite a few. There's plus and minus 30, there's plus and minus 20, there's plus and minus 15, and then there's analog 5 volts and digital 5 volts, and then there's also a 10 volt reference. All of the rails except one came up good, and I'm not sure why the particular rail is causing the system not to start properly, but it's a minus 15 volt and it's down to minus 13.65 volts. I went across to the electrolytics on the input side to the regulator, and if we just go over to here, going around all of these, measured the volts, and they seem to be reasonably good, except for the minus 15 volt, this capacitor which feeds the minus 15 volt regulator, and that was only about minus 18 volts. Put the meter on AC, and we've got about 9 volts ripple on it, and whereas all these other ones have got in the millivolts of ripple. And also putting my ESR meter onto the cap, it's reading the highest value, just a dash on the screen. Well, the capacitor's not acting like a capacitor anymore, so what I'll have to do is pull this out and replace it. So that's the first step in troubleshooting this unit. Golden rule, always check power supplies first if you've ever got a problem, and we've already turned up one. Because of the age, and also because it does actually look like, even though this one seems to be working, it looks like it's got, might be a good idea. Electro beam moment there. I forgot to unplug the mains. The power supply in this unit, the actual supply, is on all the time, and there is a power switch on the front which actually turns on the rails to the system. The idea being that it keeps the oven alive, frequency reference oven alive. So yes, so this capacitor here has also got some crud coming out of it, so that, even though it's testing okay, is probably on the way out. This dates from the early 70s. It's probably about time the capacitors, these electrolytic capacitors, need replacing. Just temporarily tacked in a 2200 microfarad 50 volt capacitor across the faulty electro for the negative rail that feeds the minus 15 volt regulator. Obviously the volts have come up, and we'll just go across here and we can see now we're reading minus 25.58 as opposed to about minus 18. And if we move to the display, the system is now at least giving us some sensible values on the display. In fact, we can change these numbers. So if I say 2 megahertz, it changes to 2, and say 3 megahertz. And if we want to change the amplitude, let's go to minus 10 dB. Oh, let's clear that. Actually, I don't know if there's a clear on there. Oh well, we'll just go 20 and say minus 20 dB. And so at least now we can get some action on the front panel. Here we see part of the A19 sweep generator board. This also has on it a small circuit that is a reset circuit for the main processor, and it just so happens that it actually uses the minus 15 volt rail. The reset uses a comparator to force the reset as long as the minus 15 volt rail is good. The rail was sufficiently out of spec to actually cause the reset function not to work, and therefore the processor, which is running on 5 volts, didn't start up. Okay, well, it's always posed to check the simplest things first. Having a look around, I noticed that the output from the attenuator board that's at the back here went to a small coaxial connector, and it was actually connected into a rear panel output rather than the front panel output. So I've just swapped those over temporarily, and we've got a nice output here, and I can go and reduce the frequency. That's at 2 megahertz at the moment, so let's put in 500 kilohertz, and there we go. And plus we can change the amplitude. It's currently at 0 dBm, so let's make it plus 5 dBm, and there we go. It looks like it's working fine, and I'll have to make sure that the leveling is working. And in fact that was the, oh there we go. Okay, so that's the slow leveling, and that's the fast leveling, and that's without leveling. So that all appears, without further testing, that all appears to be quite good. So let's go to say 13 megahertz. Wind that out, and there we go, 13.0003 megahertz. So yeah, that looks like that works fine. So really the main thing that I have to look at is I've got to repaint this and redo this decal on here. We bring this back to a grey similar to the original, and I've got to repair this switch, the tang on this switch, so I can put the cap back on, put in a complete new set of electrolytics for the plus and minus 15 and plus and minus 30 volt rails. Here's the keyboard out of the 3330B Automatic Synthesizer, and you may have noticed earlier that this keycap's missing off of here. In fact, what happened was the tang on the switch actually broke off, bringing the keycap with it. And other people have repaired these, and I'm going to attempt a repair here. But first, what I'm going to do is remove the actual key switch from the board so that I can get more easy access to try and effect the repair. The actual switch section is mounted in a plate which is screwed down to the PCB, but I really don't want to take that plate off if I can avoid it, because it means that I've got to take all the other keycaps off, and as the plastic is probably fragile on all of these, I'd rather not try to remove the keycaps. So what I'll do instead is desolder the pins up here. Just move the thing. There's pins. The pins are up here on the board. There's only 2 pins, so I should be able to desolder them with some solder wick. And then they've got a couple of plastic tabs here and here that if I push in with some pliers or whatever, that should allow me to pop the switch out without actually having to remove the rest of the keycaps. So we're going to have a go at that. And here we have the switch partly out. I've desoldered the 2 pins, and with a careful bit of prying of the 2 tabs down the sides here, and then just with a screwdriver in the end between the switch and the PCB, just slowly easing it, I've been able to free it. Now we can get the switch right out without any damage. Here I'm drilling, or have drilled, 2 holes that this little piece will fit into and produce a tang for the keycap on this switch, which is used for the megahertz button. And you can see the 2 holes there. These are 2 pilot holes to start with, using a 0.8mm diameter PCB drill, carbide tip drill, and I'm just waiting for some 1mm drills to come in so that I can drill it out to the required size, and then we can fit the new piece in and glue that down. Well, here's my repaired key switch, and the size of this was 1mm, the steel rod that I've bent up, and I only had a 1mm drill bit, so it actually took a bit of force to get this in my sometimes ham-fisted way. I managed to apply a little bit too much force, and it popped off the back end of the switch. So what I've done is reassembled all of that, made sure that the plunger will move fine, and the continuity of the switch is there, it's working properly. So we've got a bit of Kapton tape just temporarily wrapped around this while I've got some super glue just gluing the end plate back on the switch. And we used a little bit of super glue on the top of the plunger and on the replacement tang just to give that a bit of extra security, but basically mechanically it just locks into the hole anyway, so I don't envisage pulling it off, so I'm guessing that's going to be good enough for the repair. Okay, the switch is all back together and operational. So what we're going to do now is fit this back in the board. It goes down there like so. Just push him in. So wiggle him a bit to get him probably go in a little bit tight. Okay, now we just need to make sure that the pins actually go through the board. Just make sure that they go in and they're going through the holes nicely, so we can push him home. So that's that done. And with the clips that hold the switch to the backing plate, we'll just hold in position nicely. Just okay, it's done. And now we're ready to fit the switch cap. Make sure that pushes in all the way, and there we have it. Here is the refinished keyboard panel, and I've included the new decal for the slide switches. Unfortunately, just from standard rattle cans, I can't get a really good match to the colour. It's close, but a bit lighter than the original colour. So I'm not really fussed about that. It will sort of set this apart from the rest of the equipment slightly, but really I'm not overly fussed. I just want the panel to look nice. Okay, if there is a slight colour difference, it doesn't really affect the operation of the unit, so as far as I'm concerned, I'm happy. So here's the keyboard assembly with the slide switches and the key switches all reassembled, and it's ready now to be integrated back into the 3330B front panel. I first saw adapter cap on Bob Anderson's TV restoration YouTube channel, and it looked like it might be a solution for mounting the capacitors that I'm putting into the power supply, but after checking it out, it looks like the hole centers aren't right for snap-in type capacitors. Now I may be wrong in that, but it doesn't look quite right. So instead of using those, I decided to make my own. So here's the artwork for my PCB to allow me to mount modern snap-in capacitors to the HP3330B power supply. And what I've got on here, you can see on the non-component side, the blue layer, we have in copper a plus and minus sign for the capacitor, so that on the underside of the chassis you can easily identify which is positive and negative. On the silkscreen top layer on the right, I've got those horizontal bars to indicate negative terminal for the capacitor. In the centre I've got a square of silkscreen, and I've got that on both layers so that you can hand write with indelible pen the capacitor C number, making it easy to identify from below which capacitor we're actually looking at. Well, today these PCBs arrived. They came up quite well. What I'm going to do is place wire loops on this side of the board, which is under chassis side. So say between here and here, or between here and here, we can fit wire loops. We're going to have the capacitor fitting into those two holes there, and we put these wire loops on so that we can actually use them as tie points for all of the wiring that comes into the capacitors. Before I wire this capacitor up, we've got two loops of large gauge copper wire, and that is so that we can take these wires and actually J-hook them onto here, so that we've got a good reliable mechanical connection, rather than just say soldering these wires directly into the circuit board. And here's all of the wiring J hooked in on those loops, and so there's no problem there as far as good contact being made. So here we have all the capacitors replaced, the reservoir capacitors for plus and minus 30 regulators and the plus and minus 15 volt regulators. Now I'm starting to do some performance tests on this 3330B Automatic Synthesizer, and at the moment I've got it set up to produce 13 megahertz with a plus 10 dBm output. And when I initially did this, I was getting a high reading, only by about 10 hertz or so, but it was still not within spec. Going through the troubleshooting procedures, one of the recommendations is to use the external reference input on this from the counter that you're actually making a measurement of the output frequency, and that way you can at least isolate whether it's something to do with the synthesizer or whether it's something to do with the galvanized reference. What I've done here, and I'll just pan up, and we'll just zoom in a bit, and there's my counter, and the resolution we've got that counter set to at the moment is 10 millihertz, and Hewlett-Packard's specification is plus and minus 100 millihertz, so, or 0.1 of a hertz. So it's doing its job, and in fact they specify a number of particular sets of digits that essentially exercises the logic in the unit to make sure that you haven't got a problem with the actual logic and the synthesizer section. I've done those tests and they all come up fine like this, and in fact I can put in one of the test numbers, which is setting the frequency to 12,777,777.7 hertz, and you'll see the counter update, and that is pretty damn close, like spot on. So we know for sure that the actual synthesis section in the unit is working properly, and now we'll have a look at the main reference oscillator. Just for interest, we'll say just change that to 5 megahertz. And as you can see, again, it's as close to spot on as you really need for an instrument like this. You can only set this synthesizer in increments of 0.1 hertz anyway, so with it moving around by a few tens of millihertz, that's really nothing. By comparison, if we switch back to the internal reference, you'll see quite a difference. So there we're actually reading 52 hertz high on 5 megahertz signal. This is the ovenized oscillator that was originally supplied standard with this 3330B, and it's running high by about 50 hertz at 5 megahertz. The frequency adjustment is right at the end of travel, and I can't adjust it below that 50 hertz offset. So as it's a hermetically sealed module, and I don't want to break it apart, certainly at this stage. I was thinking I'll try a number of different options. Fortunately, it plugs in, and there was an option 002 that Hewlett-Packard supplied, which was what they classed as a precision reference, and that was using an HP3040A ovenized reference, which has been used in a lot of their products. I've been able to get a 10544A off of eBay relatively cheaply, and we'll see how that goes. I have to make an adapter board to plug in to the socket here that then will allow me to plug in the new reference. And I've been doing a design, currently checking this out for fitment, and this is a print of the PCB design, which will go in here. Slight modification to the original HP circuit, and I'll go into that a bit later, but essentially the board does the exact same thing.